Assalamu alaikum. How are you?
Welcome, salam. I am dead.
Why? It's your
We're good.
holidays.
Yeah, no, but I still have like a life.
Okay.
So,
Right. So previously we completed last Atelier's principle, and we also discussed about permutation combinations previously, and we thought of taking a little exam, a mini exam, right, on last Atelier's principle. So did you revise the things? Perfectly.
I'm nearly just
Yes.
skimmed.
And will you be able to write
Little
anything
skimmed,
regarding that?
yes.
If I give, I mean, don't even consider it an exam. I just
Um,
want to see how you are writing and how you are like understanding the things. Okay.
I'm probably gonna fail, but we're good. We're good.
As sorry, I just glitched out for a while. What did you say? Can you repeat again?
I'm probably gonna fail, but it's good. We're okay.
But when are you going to revise the things? Then again, you will forget these things, right? Understand?
Yeah, okay.
I think whatever you can write, I'm giving you a question. So for like 10 minutes, whatever you can write, write it. Okay. Otherwise, we are
Okay.
just, I mean, the learning doesn't get complete, right? Unless you like understand everything. Okay. Very easy question. Okay. Don't even consider it an exam. So no pressure. All right. So let's see. Is obviously a hypothetical equation. All right. Now you have to explain the effects of temperature, air pressure, concentration of reactants in the sorry not the effects of this effects of change in temperature in the equilibrium state. Okay, is the question clear to you?
Um, a bit, yeah.
Why a bit? Where is it not clear?
I think it's clear to me, but I feel like it's gonna be something where I'm gonna be like, what later?
I mean, okay, let me explain it to you. Let's forget about the language. What you have to write. See, this is a both-sided reaction. Okay, the air pressure of this particular to form this particular reaction is given to you. The states of all the elements are given to you. Okay, and the change in temperature, that is the delta H, it is also given to you. So based on that, you have to like explain the effects when you change the temperature, when you change the air pressure, like by increasing or decreasing temperature or air pressure and increasing or decreasing the concentration of reactants, and then explain what will be the effect of that. Okay, am I clear?
E yes.
Okay, I'm giving you 10 minutes. All right, whatever you can write. Okay, whatever you can write. If you don't make mistakes, you
Uh,
won't know.
just in the states, say for example, the concentration of gas. Yeah, will it
Mhm.
affect the answer?
Is concentration of any react. What did we learn about like Lasatel's principle? Concentration, changing concentration of reactants or products, it will affect the process. Okay. But in case of air pressure, we consider the air pressure of solid or liquid to be zero. Okay, we
Oh,
consider it.
okay.
We don't know if it's zero, but we consider it. So in that case, we just consider about the gases. Okay, I hope everything is clear now. Okay, all right.
Okay.
It's 8:05 now, so 8:15. So time.
Can I say what I've written? Just to see if I'm on the right track.
Sorry. While
Can I
saying,
just say what I've written so I can be on the right so I can see if I'm on the right track?
okay, go ahead.
Um, so I've written the thing down, and for temperature, I just said that the difference of heat energy would be equal to total internal energy of products and minus the reactants. That'd be six minus, which is one, not one, but like 92 kilojoules.
Yes, but why is that relevant to the question?
Which would make it an endothermic reaction. Yeah, okay.
It's not an endothermic reaction, by the way. It's an exothermic reaction. All right. Like the forward
Oh,
reaction is exothermic, and the opposite reaction or the backward reaction is endothermic. Okay.
oh yeah, yeah.
Understand my point? So that means I won't say much more. Okay, so that means then what you have to examine that if we increase the temperature, will the forward reaction increase or backward reaction increase that? And then if we decrease the temperature, will the forward reaction increase or the backward reaction? You have to examine that. And then in the same way, by like increasing or decreasing air pressure or increasing or decreasing the concentration of reactants, will the reaction go forward or backward, and so on, so on. Understand how you have to write?
Yes.
Okay. Okay, I hope you are done by now.
I'm not done, but I'm a bit lost.
Okay, so do you
Not
need
lost,
time
but like
or
a bit stuck. I
okay,
think I
whatever
need to
you have,
see an explanation.
okay, whatever you have written, just post it to the WhatsApp and I will check in the next day. Okay, and let's start our today's topic. Okay,
Okay.
all right, and you also keep on checking the things. So in the next day you can understand my explanation. Okay. Otherwise, I will keep on explaining the things repeatedly, and I mean it will be just a continuation. Okay. Why are you investing time here? Just understand that you are investing time here to learn something. But if the,
Mm,
I mean, if you obviously the process is important, the process you are going through. But if you don't get the output or the result, then I mean, what's the point, right? Okay. All right. So no worries. I hope you have written something, at least some points, some key points good. Okay. So I will check that. Let me know when you've written that on the WhatsApp. I mean, posted the image on the WhatsApp.
okay, I will.
Okay. Done.
Just trying
Okay.
too much colors. Hi.
All right. So now let us start vectors. As you said that you want to study vectors again. All right. And you had some difficulty in understanding at first, but I hope your brain has developed a little bit more and you have got a better understanding of what how directions look and like how trigonometry works. Because to understand vectors, the understanding of directions and trigonometry is really important. Okay. Okay. So now let me ask you a question real quick. What is vectors? What are vectors? Or what are vector? I mean, what is the understanding of you when I say, okay, this is a vector? Tell me.
Um, Vector is like it's like it needs magnitude as well as a sense of direction, unlike
Right.
um what's the other one? Scalar quantity.
Yes. And for scalar, it only needs magnitude. It does not need a direction. Okay.
Oh, sorry, yeah.
So if we see like vector components, we will see like velocity. Because if I say 5 meters per second, that does not make sense. We have to say 5 meters per second to the right, maybe to or to the north or to the south. That makes sense. Okay. So whenever we are saying about velocity, we have to say that okay, it goes to the 5 meter per second to the right or maybe left. Same goes for displacement. In which direction? Okay, is it upwards, is it downwards, is it right or left, anything. Okay, and again if you see time, we don't have to say like okay 5 seconds to the left. No. It's just 10 seconds or 5 seconds maybe. Temperature, we don't say like 10 degrees Celsius to the south. It's just 10 degrees Celsius. So these are like scalar components. So scalar, I mean, what did we call, okay, scalar values or something. I think let me check the term. What is scalar magnitude, was it quantity? I guess quantity. Just a second. What's the term? Okay. So vector quantity, right? Scalar quantity and vector quantity. Now, if we go towards the vector quantities characteristics real quick, okay, we will see them like vector quantity has a magnitude and direction. This is the main thing. We have already said that. Two or more homogeneous vectors can be added. Different kind of vectors cannot be added. So what do we mean by homogeneous vectors? That means say if we say like 5 meters per second and then again 5 meters per second, they can be added. Okay, obviously considering the directions. Say for instance, In case of vectors, we just don't just only say, say addition, we say resultant vector. Remember resultant?
Yes.
Resultant vectors. Say a car is moving or a particle is, no, not car. Okay, say for instance, this is a particle. So there is, say for instance, 5 Newton force in this direction and 4 Newton force in this direction. Now, when I say that calculate the addition of these vectors, you cannot just say like 4 plus 5 equals to 9 Newton. Okay, they are like two vectors, so I add them up to get 9 Newtons. No, vectors additions do not work like that. We obviously understand that the particle will move in somewhat this direction. Okay, and based on that, the 4 Newton and 5 Newton, 5 Newtons resultant force we have to calculate it. And we had a particular formula for that. I don't know if you would remember that or not. That was resultant vector equals to vector 1 squared plus vector 2 squared, squared plus 2 times vector 1 vector 2 times cosine of the alpha. That is the, like, what can I say, the angle between these two, right? So this is I will get back to these obviously in detail, but these are the things we learned while calculating the addition of the vectors or something. Now, when two or more vectors are added, then the resultant vector is equal to the result of the total action of the first vectors. Okay. So what are they saying? Say for instance, two or more vectors, the resultant vector is equal. It is equal to the result of the total action of the first two vectors. Okay, so now if I try to explain it, say for instance, say there are like various vectors here. Okay, starting from this point, starting from this point. Now, if I say that you have to calculate the resultant of this, okay, so I don't know why they're saying, okay, maybe I'm like, yeah, this term, like the resultant vector is equal to the result of total action of the first two vectors. If I put it in simpler words, just forget about that term. What you have to calculate here is that there will be some components for all these forces, right? Say this is 3 newtons, 4 newtons, 6 newtons, 8 newtons, 10 newtons, right? Is that correct?
Yes.
So these are the all the vectors from a particular point, like more than two vectors are working. So in that case, like using this formula becomes difficult. So what do we do in that case? What we do here first is we calculate the horizontal component. Remember horizontal components?
No.
You don't remember. Okay. So horizontal components are those, we get horizontal components by taking that particular value, multiplying it with the cosine and angle between the x-axis and that vector. Like this will be the angle in case of 3 newtons. So it will be say alpha. Okay. So this 3 cos alpha is the horizontal component of 3 newtons. Okay, understand? Tell me.
Uh, um, it's a lot of
Okay, if
formulas,
I
but
if I
yes.
like simplify a little bit more, say for instance, say this is a right angle triangle. Okay, so this is 3, 4, and 5. Okay, and this is alpha. So say cosine alpha equals to 3 upon 4, right? Is that correct?
Yes.
So now say for
But
instance here,
uh, cos,
this is the point. Okay,
wouldn't
this is
that
the
be
point.
4/5?
Sorry, I didn't get you. Oh,
Wouldn't
yes, yes,
cos
yes.
alpha be 4/5?
Yes, yes. 4 upon 5. Sorry about that. 4 upon 5. Yeah. That is 10 alpha, right? Yeah. 3 upon 4 10 alpha. Thank you. All right. Now, if this 4 was not given, say for instance, okay, say this is uh, or maybe this 5 is not given. Say for instance, this 5 is not given. This is like x. Okay, x. Now you are to calculate the horizontal component of this x. Okay. Now what you will do is draw us a dotted line in this direction, and also draw a dotted line is the in this direction. Okay, let me erase some of the details. Okay, now say for instance this 3 or this perpendicular axis has been transformed to this dotted axis. Can you remember that much?
I
Just
remember nothing.
imagine. Sorry.
Kind of remember nothing from the vector
No. I
chapter.
mean, just for now. Say, for instance, like
Oh yeah.
1 minute later. Okay, all right. So I'm erasing this part. Okay. Now let us erase this one as well and replace it with a dotted line. Why? I'm saying it to saying that to you. Okay, so this is in the direction. So if this is O or like the origin, this will be X and this will be Y. There is no confusion in that, right?
Yes.
Is that correct? Okay. Now, whenever you are like working with components, what you have to do is, what did I say? In case of horizontal components, you need obviously that particular value, which is x. Okay, x will be obviously needed. Okay, say I let me replace it with any other value. Say for instance, this is 5. Okay, so whenever you are trying to get the horizontal component of 5, what you will do is you will take 5, then multiply it with cosine and the angle between x-axis and that particular vector. What is the angle between x-axis and that particular vector?
Alpha.
Alpha. Alpha, right? Okay, just a second. Sorry about that. I had an urgent call. Okay, right. So where was I? So we were discussing horizontal component. Okay, am I audible?
Yes.
Okay. So horizontal components is really easy, right? Just don't get confused. Just what you have to do is that particular vector times the cosine and the angle between these two. Okay, and angle has to be in anti-clockwise direction. Write this down as well. Angle has to be in anti-clockwise direction. Has to be
Yes.
in anti-clockwise direction. Now, what do I mean by that? Okay, that might be a question. But you have completed trigonometry, right?
Yes. Sort
Say,
of.
for instance, if I give you a particular angle, this is 30 degree. Will you consider 30 degree to calculate the horizontal component? Tell
Yes.
me.
No.
Are you sure about that?
Wait. What was the question?
Say this is 5, okay, and I tell you to calculate the horizontal component of this 5 Newton. What will you do?
Oh, there it is. No, I use 330.
Yes, 330 because you have to calculate it in anti-clockwise direction, all right?
You can't have
Anyway,
negative angles. So,
okay. So now that will be 5 cosine 330, okay? And what do we do in case of, or I mean, vertical component? Everything remains the same. Just change the cosine to sine. 5
oh,
sine 330. Okay, that's it. Nothing else. You don't have to do anything else. Okay, just do the value and the angle, and in between you will change the cosine to sine. Okay. So are the ideas of like component clear or no? Horizontal component, vertical component.
yes.
What you have to do? Okay.
How
Okay.
do
Good.
you, where do you use these though?
Sorry, I didn't get you.
Where do you like, use the vertical and horizontal components?
Okay, I will get back to that. No worries. We will see maths. Okay,
Okay.
where we need to use that. All right. So in case of
Yes.
this math, you cannot just use this formula. You cannot use this formula to calculate the resultant force. Okay. So in this case, what you have to do is calculate the summation of all the horizontal components. Okay. Calculate the summation of all the horizontal components. Like it will be say 10 cosine 0, then 3 cosine, uh, say what will be the angle up until it will be alpha, say the whole one. Okay. 3 cosine alpha and so on, so on. You add all of them up. Then you also have to like summation of fy. This will be 10 sine 0, and then you add them up. Then what will be the resultant? After all, the resultant will be equal to root over square root of f of x square. I mean fx squared. That means the summation of all the horizontal components squared plus summation of all the vertical components squared. So that is the use. And also there are other uses as well. You will see them. Okay. Many things get easier when you use vertical and horizontal components. Okay. We'll get back to that. Anyway, the vector product of two vectors is a vector quantity. Now, what is a vector product? We'll come back to that. And the scalar product of two vectors is a scalar quantity. We consider the scalar product to be dot product as well. Okay. We consider dot product as well. Write that down. And vector product is also said to be cross product. What did I say? The vector product is also termed as cross product, and scalar product is termed as dot product. Okay. Scalar product is termed as dot product, and vector product is termed as cross product. And vector quantity obeys the rules of addition and distribution. That means if you like have, say for instance, x vector plus y vector. Okay, so yes, you can write it like that, x vector plus y vector. Or say for instance, if you have x vector plus y vector times by, it's not a cross product or something, just times by, say for instance, a. Okay, so you can write it like ax vector plus ay vector. Okay, a is like what is a constant, say for instance.
So you
And
just
vector,
apply,
yes,
so you just apply, the normal algebraic things on that.
If you multiply it with, like, say, a constant value, say this is 5, 6. If you multiply x vector with 6, it will be 6x vector. Okay. All right. But the thing I mentioned, like cross product and dot products, these are different things. These do not act like the normal multiplications. Okay. Understand my
Mm,
point?
mm.
And vector quantity can be divided into components. All right. So these are the basic properties. We have read them before and we revise them as now as well. Okay, let me give you another link. Join fast, okay?
Okay, bye.